Look around you right now. Everything is spinning. The Earth beneath your feet rotates once every 24 hours. The moon circles overhead, spinning once every 27 days. The sun itself turns once every 25 days at its equator. Every single planet in our solar system spins. Every moon, every asteroid, large enough to measure, our entire solar system wheels around the center of the Milky Way galaxy. The Milky Way itself rotates. Every galaxy we have ever observed rotates. Galaxy clusters orbit each other. Even the largest structures in the universe have rotational motion threaded through them. Go smaller. Hurricanes spin. Tornadoes spin. Water draining from your bathtub spins. Every electron in every atom possesses intrinsic spin. Every proton, every neutron, every quark, even the photon, the particle of light itself, carries angular momentum. Go to the extremes. Pulsars, the collapsed remnants of dead stars, spin hundreds of times every single second. Some spin 700 times per second, faster than any kitchen blender. Black holes spin. The fastest rotating black holes spin at nearly the speed of light at their event horizons. Everything spins. Everything rotates. Everything possesses angular momentum. Is this just a cosmic coincidence? Or is there a profound physical reason why rotation dominates the universe at absolutely every scale? From the smallest subatomic particles to the largest galaxy There is a reason, and it is one of the most beautiful, most powerful discoveries in all of physics. The universe spins because angular momentum is conserved. Not sometimes, not approximately, always perfectly. Without exception, this conservation comes from a deep symmetry in the laws of nature. Rotational symmetry. This insight comes from Noether's theorem, one of the most profound theorems ever proved. Noether showed that every symmetry in the laws of physics corresponds directly to a conserved quantity. Time symmetry gives us conservation of energy, spatial symmetry gives us conservation of momentum, and rotational symmetry gives us conservation of angular momentum. At the quantum level, spin becomes even stranger. Spin is not just classical rotation, it is woven into the very fabric of spacetime itself. Particles possess spin without rotating in any classical sense. The electron does not spin like a tiny ball. It is a point particle, yet it has angular momentum built into its quantum nature, and this quantum spin has staggering consequences for everything. From the structure of atoms to the stability of all matter, to the behavior of black holes. Why is angular momentum conserved? The answer comes from Noether's theorem. The laws of physics look identical in every direction. There is no special direction anywhere in the universe, no preferred axis. Rotate your laboratory by any angle, and the laws of physics remain completely unchanged. This rotational symmetry means that angular momentum must be conserved. Always exactly. Without exception. If the laws have no preferred direction, then no physical process can create or destroy angular momentum. It can be transferred between objects, it can be redistributed, but the total angular momentum of any isolated system remains constant, forever. Where did all the rotation in the universe come from? Let me give you an example. Stars are born from enormous clouds of gas and dust stretching across light years. These clouds are extraordinarily diffuse, far less dense than the best vacuum we can create in any laboratory. In certain regions, gravity becomes strong enough to overcome pressure, and the cloud begins to collapse inward. Here is the crucial point. The cloud was never perfectly stationary. It had random motion, with atoms and molecules moving in every direction. It was turbulent, with eddies and currents flowing through the gas. When you add up the angular momentum, the total is not zero. It might be small, but nearly zero is not zero. And here is where conservation becomes dramatic. As the cloud collapses, its size decreases. Angular momentum is conserved. The same angular momentum concentrated into a smaller volume. As radius shrinks, rotation rate increases. This is the ice skater effect. When an ice skater pulls their arms in while spinning, they spin faster. A molecular cloud collapses from light years down to the size of a solar system, a trillion-fold decrease in radius. the angular velocity must increase by a staggering factor, a cloud spinning so slowly that one turn takes longer than the age of the universe becomes a rapidly spinning star, completing rotations in just days. The collapsing gas cannot fall straight to the center. It carries angular momentum, which prevents direct infall. Instead, the gas spirals inward, forming a rotating disk, and from this disk, planets form. This explains why the solar system is flat, why all planets orbit in the same plane, in the same direction. Everything traces back to the initial angular momentum of the collapsing cloud 4.5 billion years ago. The same physics applies at larger scales. Galaxies form from the collapse of massive overdense regions in the early universe, seeded by quantum fluctuations during cosmic inflation. Gravitational pull from neighboring regions caused torquing, transferring angular momentum to the collapsing regions. This is why essentially every galaxy rotates. Our Sun orbits the Milky Way at 220 kilometers per second, taking 230 million years to complete one orbit. One galactic year. The rotation curves of galaxies reveal something hidden: dark matter. If galaxies contained only visible stars and gas, orbital velocity should decrease with distance. But observed curves are flat. Velocity stays constant far beyond visible stars. This tells us there is invisible mass extending far beyond, providing extra gravity. The rotation of galaxies gives us our most direct evidence for dark matter. When a massive star exhausts its fuel, the core collapses catastrophically. In a fraction of a second, a core the size of Earth collapses to just 20 kilometers across. Angular momentum is conserved. When the core shrinks by a factor of 500, rotation rate explodes upward by a factor of 250,000. A core rotating once per day becomes a neutron star spinning hundreds of times per second. The result is a pulsar, sweeping beams of radio emission around space. Some pulsars spin 700 times every second. The fastest completes 716 rotations per second. Its surface moves at nearly a quarter of the speed of light. Pulsars are conservation of angular momentum, written in fire. Black holes spin too. This is fundamental. When matter falls into a black hole, it brings angular momentum. The black hole must acquire it. Black holes are described by just three quantities: mass, charge, and angular momentum. Nothing else matters. This is the no-hair theorem. The rotating black hole drags space-time around with it. This is called frame dragging. Anything near the black hole, even light, is forced to corrotate with spinning. There is a region called the ergosphere where space-time is dragged so violently that nothing can remain stationary. Roger Penrose showed you can extract energy from a rotating black hole by sending matter into the rotational energy of a maximally spinning black hole is staggering. Up to 29% of its total mass energy. The most energetic phenomena in the universe, quasars, gamma-ray bursts, relativistic jets, might be powered by the rotational energy of spinning black holes. Now, quantum mechanical spin. Every fundamental particle possesses intrinsic angular momentum, called spin. But particles are not spinning balls. The electron is a point particle with no size, yet it possesses angular momentum. Quantum spin is profoundly strange. Measure electron spin along any axis. You get either plus or minus 1/2. Never anything else. Rotate an electron by 360 degrees. You do not get back the original state. You must rotate it by 720 degrees to return to the original state. Nothing in everyday experience behaves this way. The spin statistics theorem is one of the deepest results in quantum field theory. Particles with half-integer spin are they obey the Pauli exclusion principle. No two can occupy the same quantum state. Particles with integer spin are both. They prefer to pile into the same state. Lasers work because photons are both. This difference comes entirely from spin and determines the structure of matter. Fermions make up matter. Bosons carry forces. Emmy Noether proved that every continuous symmetry corresponds to a conserved quantity. Translational symmetry gives conservation of momentum. Time symmetry gives conservation of energy. Rotational symmetry gives conservation of angular momentum. The reason angular momentum is conserved is that space has no preferred direction. If there were a preferred direction, the universe would be unrecognizable. Our solar system demonstrates this beautifully. All 8 planets orbit the Sun in the same direction, in roughly the same plane. This is angular momentum conservation. The solar system formed from a single rotating cloud. When it collapsed, angular momentum was conserved and distributed among resulting bodies. The entire system carries the memory of that rotation from 4.5 billion years ago. This is why the solar system is flat. Material could not fall straight to the center. It orbited, spreading into a disk where planets formed. Earth's rotation creates the Coriolis effect, deflecting moving objects sideways. This is why hurricanes spin counterclockwise in the northern hemisphere, clockwise in the southern. It explains trade winds, the jet stream, ocean juniors. The entire climate system traces back to Earth's rotation, to angular momentum, inherited 4.5 billion years ago. The moon is tidally locked to Earth, always showing the same face. This resulted from tidal friction over billions of years. Earth's gravity raised a tidal bulge on the moon. This bulge was pulled backward, slowing the moon's rotation until it synchronized with its orbit. The lost angular momentum was transferred to orbital motion. The moon moved farther from Earth. Earth's rotation is also slowing. Our day is getting longer by 2 milliseconds per century. 4 billion years ago, a day was only 6 hours long. Rotating charged objects create magnetic fields. Earth has a magnetic field because its rotating interior contains conducting liquid iron. The dynamo effect generates our protective magnetic field. Neutron stars have the most powerful magnetic fields in the universe, trillions of times stronger than laboratory magnets. These arise from compression during collapse. The combination of intense field and rapid rotation makes pulsars pulse. Where did the universe's angular momentum come from? During cosmic inflation, quantum fluctuations were stretched to cosmic scales. These fluctuations carried random angular momentum on every scale. Total angular momentum appears to be 0, but locally, fluctuations carried rotation. When overdense regions collapsed to form galaxies, they brought angular momentum with them. The spinning of galaxies and stars comes from quantum fluctuations, preserved and amplified by collapse. Angular momentum conservation creates stability. A spinning gyroscope resists changes to its orientation. This is why Earth's axis points steadily toward Polaris, maintaining seasons, keeping the night sky predictable. Modern spacecraft depend on gyroscopes for navigation. A conservation law transformed into a precision tool. Everything spins because angular momentum is conserved. Once created, rotation persists. There is no friction in space. Initial conditions always include angular momentum from quantum fluctuations, turbulence, tidal torques. That rotation is conserved through collapse. Collapse amplifies rotation dramatically. Quantum spin is fundamental, woven into quantum fields. Rotational symmetry is universal. The laws of physics are identical in every direction. This is confirmed by every experiment. Imagine a universe where angular momentum was not conserved. No planetary disks, no magnetic fields, no life, no pulsars, no weather patterns. Without spin, atoms could not be stable. No chemistry, no matter. The universe would be formless, lifeless. Everything depends on angular momentum being conserved. The spinning of things is a fundamental pillar of reality. Spin is everywhere because angular momentum is conserved, and it is conserved because the laws of physics are indifferent to direction. Rotational symmetry is absolute at every scale. This is something we discovered, confirmed by every test. Because of this perfect symmetry, everything that was set spinning continues spinning. Planets spin because their parent clouds were rotating. Galaxies spin because quantum fluctuations carried angular momentum. Neutron stars spin because cores conserved angular momentum through collapse. Electrons possess spin because they are excitations of quantum fields. The universe spins at every scale. From superclusters to quarks, angular momentum is there. Conserved, persistent, fundamental. When you watch a gyroscope, you see a conservation law in action. When you see a hurricane, you see 4.5 billion years of conserved angular momentum. When you look at Saturn's rings, you see conservation laws from 4 billion years ago. The universe spins because it has nowhere else to put its angular momentum. Conservation is absolute. The symmetry is perfect. The mathematics is exact. And that answer becomes more beautiful every time you consider it. This is physics at its most powerful. This is the universe revealing its deepest symmetries. This is why everything spins.